Hi, everybody. I thought I would make a very short video going over a section of the chapter on omitted variable bias, a section that we did not cover in class explicitly, but it's very useful to cover this thing now, so now we'll make it up. This is chapter 8, Understanding Omitted Variable Bias, and this was section 6, called A Tale of Two or Three Regressions. The idea here is pretty straightforward, that if we have a regression, and we'll do it in the single variable regression case where we think there's an omitted variable, so we have an X variable that's explaining the outcome Y, but we think there's a third variable Z that's omitted. We can think of this in terms of two regressions, one that we'll call the short regression that does not include the omitted variable, and then another that we'll call the long regression that does include the omitted variable and hence has one more term and so is longer. So we're in this section, tale of two or three regressions, and here's our short regression. So we just have yi and the x1 is just the x variables, our regression, our explanatory variable. And here we have x and the z. So now we include the omitted variable. So this coefficient B2 in the long regression is our unbiased estimate of the, I'm sorry, this B1 in the long regression is the unbiased estimate of the effect of X on Y. It's unbiased because now we've included the omitted variable. And this B beta 1 in the short regression is the biased estimate. Now, it's possible to show that the biased estimate is equal to the long regression estimate, which is the unbiased estimate, plus the coefficient beta 2 in the long regression times this term pi zx. And pi zx is the coefficient on the regression of z as the outcome variable and x as the explanatory variable. So we have a third regression. So a tale of two or three regressions, the short regression, the long regression, and then this third regression of the omitted variable z as the outcome variable and the explanatory variable x as the main explanatory variable. And we can show that the relationship, the nature of the bias is this term, right? The bias is the difference between the true coefficient and the coefficient that we estimate when we don't include the omitted variable. And that's equal to this, the difference between them is equal to this term. So if we had the measure of the omitted variable, we could do this kind of regression anatomy, it's sometimes called, this forensic accounting, and see the extent of the bias. And we can do that, just for fun. We can do that with our Kenya data as we do down here. So we'll run the Kenya data and we have the three regressions. So we'll have log of earnings as the outcome variable. So here's our short regression. We'll just have education, rural, as the dummy variable. That's our included variable. So we get a coefficient of minus 0.668. But plainly, people who are rural are earning less because they have less education. So that's the omitted variable. So if we include in the long regression, we have now rural and education. So in this regression, we have two variables in the regression. Indeed, our coefficient goes down. Our estimated coefficient on rural goes down to negative 0.45, and we have a coefficient on education years of 0.117. Then we can, so education years is our Z variable. It's our omitted variable in this little example. So now we have our Z variable as the outcome variable and our X variable from the first regression, rural, is the X variable. We get a coefficient of negative 1.88. That's our pi ZX. Then we can go to that little formula that we gave above, and that's right down here, pi ZX. And we have the negative 1.8. We have the 1.17 here. That goes right in here. And we have the negative 0.45 there. That's right here. And then we get, of course, this coefficient, which is this coefficient. Yeah, it's off by the third decimal because of rounding. So that's another way of seeing what the nature of the omitted variable bias and the direction of the bias is if we do have that third variable. Of course, if we have that z variable to begin with, why would we have ever estimated the biased equation? So this is purely for sort of forensic accounting purposes and not because we would deliberately exclude it and then include it just to see what the direction of the bias was. But it confirms our reasoning of the direction of the bias in this particular case. So hope that's useful to you, and I encourage you to read these 2 short pages. It will help you understand omitted variable bias more.